going on, everyone out there in Global Hack Week land? Let me know if you are in the chat with me. Let me know where you're joining from. And yeah, give us a shout out if you're joining for the first time. If you're familiar with Auth0, which is the workshop content we're about to get into, let us know. We've got a little bit of housekeeping at the top of the hour here. We're going to be doing some registrations and check-ins, so be sure that you click in on the link that's scrolling along the bottom. I've also dropped it in chat for y'all. Register and check in so we know that you came. Honestly, we've got some great content in store for you today. If you're familiar with Auth0 as an authorization and authentication as a service platform, you might be interested to learn that you could also utilize the same service that you've come to know and love with some awesome AI capabilities, which is the theme of this week's Global Hack Week. So once again, I'm Rosendo from MLH. Really happy to be here. We've got a great speaker in line for y'all. And really just show them some love. Make sure that y'all pay attention and listen. Ask any questions that you have, drop them in the chat. But really, without any further ado, we're gonna go ahead and bring Fred Patton up on the stage. So give him a warm welcome, y'all. How's it going, Fred?
Hi, everyone. How you doing today? I can hear the love. Very good. Thank you. Yeah, so I'm a developer advocate at Auth0, focused on our new emerging AI applications. And so today we're going to talk about governing AI agents with MCP and MCP with Auth0. So, when we think about an agent and we think about co-pilots and a lot of things that go before, and we think about what an agent actually is, identity becomes increasingly important because identity turns a bot into an agent. So you go from performing tasks to assuming roles on behalf of a user. And then without an identity, there's no accountability and auditability. And so if you want to be able to take actions, remediate, do those type of things, it's really important to be able to capture all this. And so Auth0 gives agents, the precondition to exist as first-class actors in a system. So usually, when Auth0 comes up and we're talking about AI agents, we're just thinking about security, but really that's just the floor, because once you take care of some of the security concerns, then you can really focus on enabling it and taking those next steps. So if we think about LLMs and agents and all of this, initially LLMs are basically just responding and quite effectively based on the data that they've trained on. And so you can get all kinds of, as we know, great answers, code generated, all these different type of things. But then what happened next is that, okay, that's cool. How can we kind of harness our company data, our organizational data? So then, we had all these iterations of RAG and being able to basically inject just-in-time context to be able to allow the agent to do the same thing that it did with its training data, basically, on your organization's data and on real-time data. So that was cool as well. But now when we're basically having tools and taking a lot of actions, then we have the individual users. And so before, personalization was basically looking at a particular user's past interactions with the agents and using that context. But with tool calling, it opens up a whole new area, right? Because users have all these siloed external applications, right? All these different services, be it Slack, Google, GitHub, Stripe, what have you. And so now agents are actually able to take actions for specific users with some super deep personalization and access to related data. But who wants to trust an agent absolutely with their creds on all these different apps? Because as we know, bad things can happen. And so it's one thing if it happens to AWS or someone like that, but it's another thing if it happens to our data, especially if money's involved or sensitive stuff. So by just putting in some managing identity in your agent, you're able to give users a reason to trust and absolves you from a lot of risk and then basically unlock a lot of new features. So I like to think about it instead of just defensively with security, basically opening it up to allow users to really go further and trust your agents and not expose themselves to unnecessary risk. So what is Auth0 for AI agents? So it's there's four basic pillars, right? In order to be able to do things for users, it's important for the agent to be able to know who that user is. So authentication is very important. And for users' convenience and different security settings, it's important to be able to allow all sorts of different things. So, you know, since we're doing tools, username, password is probably not what we want. We probably want to be able to do social auth. Maybe we want to do things like passkeys and biometrics, whatever that is, depending on the particular application. So user authentication is what allows the agent to understand who they're really talking to, and then when we go and use the tools to be able to make sure we're only accessing users' information for the right users. And along those lines, to be able to access those applications, we don't really want to hand the agent all the credentials like I mentioned before. So what Token Vault allows you to do is that it manages those sensitive credentials, and then when an agent needs to take action, they get basically short-lived, scoped access tokens so that they can do the particular things on behalf of the users that are kind of very specific. So think of it this way: you might invite people into your home, and that's one thing. But you might not want them to go all over your home without you there and do whatever they want to do. So this is the same idea, right? We want to be able to allow agents to do things with our data, but not just anything that they want. So that's what Token Vault allows you to do here. And then asynchronous auth. So let's say your agent can use tons of different tools, right? You don't want to, when they sign up, you don't want to have them just say okay to do everything, and you want to basically do just in time. So okay, if they don't need to do certain things, then they don't need access to that. So what this does is that it allows you to check with the user at the last minute whether or not they want to basically unlock a new layer of authorization and give them kind of full context about what's going on. And then even if they have authorized something, you want to be able to sometimes approve very sensitive operations like, okay, go search and find me this rare album, right? Okay, it finds it. Do you want to just go spend the money, or do you want to maybe have a second check and verify that you want what you want? And so how async auth works is that you could even be at lunch or somewhere else, and then you just get a message on your phone with all the context, and then you're able to basically approve, allowing the agent to go ahead and continue with that background operation. Or if you don't approve, then even if the agent tries, it won't be able to successfully um, use that because the token won't be authorized for that. And then lastly, fine-grained authorization. Um, you've heard these stories where you're able to trick an agent and download whole databases and do all these kind of things. Well, you can fool an agent eventually if you do the right, if you're persistent enough and use enough techniques. But you can't fool an access token. And so what fine-grained authorization allows you to do is, instead of just having these very granular things like, okay, developers or managers or whatever type of thing that you're having it in there, you can basically take your own model, your own data model, and partition the access in a very granular way. Maybe it's that I have access to a certain resource normally, but maybe I don't have access if it's outside of working hours, or if I'm on an unknown IP address, or um, you know, other things like that. So, or maybe you can um, do this normally if a certain um, external condition has happened. Like maybe if a case is opened, you're able to look at this data. Otherwise, if the case is not open, you're not normally able to go in there and look at that report, or if you're not assigned to it. So that's the general idea. So basically, that's where Auth0 for AI agents comes in and helps. So we kind of talked about this. There's different ways um, to authorize users, and the same applies when you're dealing with doing things on behalf of users with agents: username and password, social logins, passwordless and passkeys, single sign-ons. So we kind of talked about this. Why does it matter? Secure and controlled access, auditability when something goes wrong, or asynchronous approvals, or rolling things back, any kind of mitigations that need to happen. You want to be able to not just know a certain agent was doing something, but who it was on behalf of, and all the context that you have around how that agent got authorized to be able to do something. Uh, could use it for agent identity and then kind of delegation stuff on for users and so forth, and then personalization. And even on the, you can think about agent identity, where maybe it's agents needing to know who each other are, so you can do machine to machine authentication using things like, client secrets, which are hijackable, so you can have more secure sender constrained ones like mutual TLS or DPoP, or you can do private key JWT, so that you can use PKI to kind of back it, so that when someone steals a cred, it won't work. And then delegated authorization. So I kind of mentioned a client initiated back channel, which enables async auth, device authorization. So various different mechanisms available. So yeah, we talked about user auth. AI needs to know, the agent needs to know who I am, and to call things on my behalf. Um, it needs to be able to do that in a controlled way, where it's only getting the least privileges needed. So you don't want to give credentials. You just want to give very scoped, specific, short-lived um, access. Async confirmation to keep the human in the loop factor. Give those approvals. Give that context. And then, like we were talking about with fine-grained authorization, RAG is the most common one. You can also use it really for, even for tools themselves. Like you might put this on a tool level about what tools can be used even. So, but RAG is what we see mostly. So yeah, those are the basics. Uh, User auth, tool calling, async auth, and then fine-grained authorization. So to call your own APIs on a user's behalf, that's a specific flow where, again, everything starts with user auth. Then we're able to basically do that, issue a token, and that token, that specific scope token, will go to the agent so it can make tool calls, and that token will be forwarded through. Then, API validation and response will happen, and then agent receives and processes the information. There's a QR code there if you wanted to click it to find more details on that, including example code. Go ahead and capture that. Then what we were talking about is being able to allow agents to call your external applications, be it Gmail or Washington Mutual, or whatever it is. So, securely store and manage tokens, maintain user context, provide a seamless user experience, and enhance security. So to do that, Auth0 provides integration with a number of different frameworks. If you're doing things JavaScript, Python, using LangChain, Llama Index, Versal API, Cloudflare. There are some more. The interesting thing is that you can use you can use the SDK directly for that kind of low level thing. But if you're already using these other frameworks, a lot of this stuff gets um, out of your way and handled automatically. So in a lot of cases, if you're using like Llama Index or Vercel, you would be basically mostly doing what you're already doing, and the added security and those hooks happen beneath. And when we look at some of the code, you kind of might see that how it's a much simpler flow than usual. Now, we could talk about highly regulated identity for a case. So usually with your agents, it's doing things for you and me and users of social sites and that kind of thing. But sim- in some kind of sensitive domains where failures can be catastrophic, can end businesses, can be huge deals. They're finding they want a little more defense than just basically relying on OAuth2 bearer tokens. So highly regulated identity provides a stricter set of security standards. We saw some examples of sender constrained tokens and those things earlier. This is where they come into play. So financial grade API, it's no longer focused just on finances, healthcare, all these other things. And so they kind of removed that name from it, but they still call it FAPI. And it's basically a hardened profile with OAuth OIDC protocols. So there are a lot of optional things that you can do with normal OAuth. What this does is that it removes any optional things that provide security vulnerabilities, and so a lot of there are optional ones that just get removed because they open a vulnerability, and there's optional ones that increase security that are then no longer optional, but then they're mandatory, like with Pixie and some of the other things. So basically, this is a really hardened kind of approach to doing OAuth so that you don't expose yourselves to a lot of vulnerabilities. So it requires stronger proof of user and client identity, and then really basically a zero trust footing. So there's a few chief ways where agents become risky. So we kind of talked about the bearer token, right? Those tokens you can kind of think of as cash. Why? Because if you go in and hijack um, that token, you're able to go use it, right? It's anyone can use it. It's just like if you find the $20 bill that I dropped on the sidewalk, you can spend it just as well as I could have spent it. So that's the whole idea. And so that might fly for general purposes, but um, sometimes you need a little more protection. And another big area is overbroad permissions, right? Agents often have generic scopes like bank right, um, but that's very kind of open, right? Just like read write access, when you can do all these different things and it requires on all these different conditions, you want kind of specificity and kind of generally some kind of transactional specification involved with it, so that we'll you want more protection. And then data leakers and URLs, right? Agents often pass data in browser URLs, and with spying eyes and there's all kinds of ways to link sensitive content in those URLs. So that's the kind of standard thing that passes, but it's highly regulated identity is about not allowing these kind of vulnerabilities. So here's how we can secure the AI agents. We can use basically sender constrained tokens, things like MTLS, or um, demonstrating proof of possession. So basically, the tokens are bound to an agent cryptographically, so that you can't just find this token. You have to be able to, when you make a request based on that token, that's another operation where you're using a private key. And so your request is basically assigned. And so whoever's validating that will basically realize that, okay, it doesn't match. Someone else has written this request. So they happen to get the token somehow, but we can see that it's not really the same entity that's requesting something. So it just gets blocked. So that's important. There's newer specs like rich authorization requests and dynamic linking, where basically, the agent needs permission for a specific transaction. It's not just general access, so that if that token gets compromised, or if the bad guys get in there, what they're able to do is strictly limited. And then in other areas with push authorization requests, so sensitive data, is sent via back channel. We talked before about how you can do things with URLs and those other kind of things. Well, you just keep it out of there entirely, because that's a huge vulnerability and gets leaked out. So in a nutshell, for a highly secured agent, you're going from things like bearer tokens to sender constrained tokens. You're really tightening those permissions so that they're kind of more specific and transactional. Imagine approving someone to do a $50 transaction versus a $5,000 transaction. You kind of want that to be in the permissions. We avoiding leaky URL parameters by using the back channel. Um, and then when these things are signed, you have that proof. And so that's all in the logs, where not just not just that someone was authorized, but exactly how they were authorized, and just being kind of very rigorous about failure modes. So we'll jump in and talk about MCP, and then we're going to go into do a demo and look at the code. So yeah, why MCP? We won't belabor this too much, but before MCP and using these tools, you had to keep redoing a lot of the same stuff. There was no uniformity, so to do this tool was different work from doing another tool, and so you have all this custom logic, and it was kind of really brutal, a lot of mess, and then you do everything right and it works, but then um, tools are changing, so then you're back at square one or less than one, because you're already live and things are broken. So with MCP, it allows complex actions, really the confidence of tool calling. Just think about mathematical operations. AI agents are doing all these very cool things, answering deep questions, doing all this analysis, and then you give it some moderate math problem, and it totally kind of hurls it. So think about doing your TAM or whatever projections you're trying to do, and getting some nonsense out. So that's a big deal. Real-time tool discovery, composable multi-step actions, rapid app development. So, MCP makes tool calling way better. So you're basically going from, this hodgepodge on the left to basically having that server being able to go and access, those tools in a very consistent and uniform manner. So, and additionally, it allows us to enforce scoped identity-bound least privilege access, manage consent flows and per client permissions, all again in a nice uniform way, secure credentials via things like token vaults and token exchanges, um, auditing, lifecycle events, and basically, um, putting some guardrails around those agents. So, yeah, an Auth0 case, since we're talking about that, the customers of your app, the users of your app might be employees, they might be just other users. In any case, it's all the same thing. They'll go through authorization, and then whether it's tools written by external developers or your own, it's still the same type of thing. And so it really gives a much cleaner and tractable way to go and get a solution out. So I'm going to do a demo, an MCP demo, and it's going to be basically a web app where you're allowed to do task management. And then it's going to have, there's going to be an MCP agent that's able to go ahead and do the same things without that UI. So you're able to go and actually run this yourselves as well. And let's jump in and take a look. Let's jump over here real quick. I left this. Okay. So we're going to open up the web app here, and then we're going to open up the agent here. Okay. So yeah, remind me about that later. So let's go. Let's run the web app, and I'm going to sign in with my demo machine. It's not my first time signing in, so I'm already going to be authorized for a lot of things. What we're seeing here are a number of different projects. Okay, I've got a demo here. We'll click that, and here are some tasks. Okay, let's just create some tasks. Before we do that, let's go open the AI assistant. That's also going to be able to utilize the same data. So show me my tasks. Okay, I've got two tasks in here. Test task, which is in to-do status, and let's eat. This is also in to-do status. So going back here, okay, that's what we had. I'm getting hungry. Let's move this to in progress, and let's create a new task here. Let's see here. Yeah. So here we go. We're going to say MLH for the win. Give a workshop to people you can't see, and we'll assign it to myself. We'll put it on for today, no time like the present, and this is urgent, right? So let's create that task, and we should see it below. Let's just quickly create one other task here. Verification, verify task. Okay. Quick test. We'll assign it again to myself. We'll make it for today. Oops. Did I lose that? I think I did. Apologies. Verify. Quick test. Okay. Assign it to myself for today. And we're going to just say test. All right. So now we're going to create a second task. And this one we'll just move up here just to make sure everything's honest. And even let's move to eat as done. Okay. So now we can go back to the tool and we can say, I think my tasks may have changed. Show them again. Okay. All right, so you can see that they are in sync here. We've got everything in the state that we expected. Let's eat is done. We did that. We'll just try creating a task. Create a task with the description. Um, Test from agent with status to do. We'll just say in progress. How about that? And due date December 12. Okay, no one cares about the format, and tags. Let's go test. All right. So now if we do this, we should be able to have that task created and be able to basically verify that it gets done on the other side. So it claims it did it. Did it really do it? Let's refresh and find out. Click my demo. Test from the agent. There we go, in progress. Let's click into it if I can. No. Let's get, also, I forgot to show this stuff. So here again, we're showing about the authentication. What are the scopes involved? It shows that I'm able to read projects. I'm able to write projects. I'm able to read tasks. I'm able to write tasks. And then it talks about tools that were used. So it's using a tool to list the projects. So we see it's listed a bunch of my projects here. Very cool. Then it's able to create tasks. So this was that last random task that I did. And then it uses a tool to update the task status, because instead of just having it be in to do, we decided to basically let it be in progress. That's cool. That's probably enough stuff to look at for this demo. You guys are able to run both of these yourselves and create tasks and run it in the MCP. Also, if you're using Claude or something, you can go ahead and access the MCP server from there. So I invite you guys to explore this further. I think we can now go ahead and look at the code that we've been running. So this is in GitHub. There should be some link in there. It's the Auth0 Task Vantage project. So let's start by jumping into the agent, and hopefully this is clear enough for everyone to see. We'll jump first into tools. So here we're using function tool from Llama Index, and we've done our own function that we'll look at later to create the MCP client. So we're going to do some tool tracking stuff, which we can skip through to get to mostly what we're doing here is the creating tools. So we've got our local tools. So sometimes tools, like, you can have something simple that's very useful, like get current time, right? We don't need a real MCP tool for that. We don't need authentication or authorization for that. We can simply have it run some JavaScript, like, give me the date. So get current time is that simple. So there's no parameters to pass in there. So there's no properties, empty method, and we simply create a new date, and output it to an ISO string to be able to have the agent get the current time. And similarly, we can do the same thing for calculations. So we can simply have a parameter that's basically a string that has the expression. Then we're going to sanitize that expression so that we get rid of any kind of non-mathematical stuff that's going to, blow up the formula. And then we can basically run that as well ourselves and then get the result. So here, so here we'll just basically run the function and output the result. Cool. So those are quick examples of how we might create local tools to do things. Then also we want to be able to create other tools. So we'll start by creating metadata so that the MCP handler that we're going to be able to use can utilize what we're doing. So we'll dive into that. We're wrapping all the tools with metadata and adding those to the list. And now we're going to want to be able to create a client and pass that access token. You could pass a null access token. It might be cases where no authentication or authorization is needed. Oh, QR codes have expired. Okay, my bad on those. And then, so here we'll go through and basically wrap those tools with the metadata and add them to a list. And so we're going to basically return the list of wrapped tools, that metadata, and then we're going to pass a cleanup function to clean up after ourselves. So it's just there, and we can jump to MCP here. Okay, cool. So here, we're going to basically take care of the transport and the connection. So we're using here we're using the MCP SDK directly. So it's going to be more verbose and low level than what it typically is if you might use something higher level. But so here we're creating a client where we're going to pass some transport options. If there is an access token, we're going to expose that as the bearer token there. Then we're going to use the streamable HTTP client transport for that connection. And we're going to basically create our MCP client, give it a name, version, and make that connection. This will allow us to be able to list the tools. And so we're going to take those tools and wrap them so that we can use them. So we're going to basically be exposing a list of tools, an API for calling the tools. So let's check out what's going here. We're going to be able to get exchange of scopes, and the thing to call here is basically the call that you see here to where is it for call tool that we had? Okay. So we're using the client to invoke its call tool method, and then if it's the first time we're connecting, we want to get the token exchange time. In some cases, that's important because the clocks on the server and the clocks on the agent can be out of sync. So we'll get all that stuff, and that way we are basically able to exchange return the exchange scopes and then the token exchange time. So that's to get metadata call. We're passing the cleanup function, And then again, as before, we're also returning tools and call tool. Memory.js is very simple here. We're building that state for the particular user for the tool usage. So we're going to basically, we're using from llama index, create memory and static block. So we're going to start by pushing that initial static block that basically just shares in the context what the user's display name is. So it can say, hey, Fred, I'm your helpful dude. I'm going to help you out. And then we're going to provide some specifications around the memory, and then we're going to be set that to that user's key so that we're able to use that as things go on. Okay, we can jump to tools next. Under here, all right. So yeah, we can start looking at, did I get these guys? Yeah, so I was talking about before how we're wrapping the metadata. This is that function call. We're tracking all the context that we can with the time and basically auditing it so that whenever an agent does an operation, it can return basically all the tools used and what happened, kind of like what we saw when we were displaying the tool use. So that's how we do it here. Again, we show the local tools and those specific tools. So I will move on and we can look at, I think, the agent. Yes, great. So here we're using OpenAI and llama index workflow. And the prompt is kind of detailed. It's, it's based around task management. And when we look at the tools, we're going to see you don't just have like some monolithic update method, but in order to improve the reliability, we're going to have very specific separation of concerns type thing for the tasks. So by having more granular tasks, we can improve the agent reliability. So we won't go through that whole big blurb there, but here you're able to get a user type. What I was using was just a regular user, so the same thing that you would see. If I had used my Okta account, then it would map me to a B2B customer and something else, but basically I just did guest access just as you would. So getting the auth context is important from the request to, to be able to find the token set within the MCP audience. So we pull the session, then we're gonna search that session for the right token set that has the audience we're looking for. So we're looking for MCP Auth0's audience, and that'll flag the right token set that we need, and pull out some internal user type information. And so this is the main chat endpoint of what it does. So again, you can come in authenticated or not. That's all fine. We're going to basically create log IDs so that we can trace everything in a cleaner, auditable way. So we pull that execution context. That's mostly the access token. We're going to pull the user type and user ID out of there. And of course, we have to have the message. We're going to pull that memory for the user so that we can build up the context as they go along. And then we're going to pull the tools, basically local, and then the other MCP tools that are involved there. And here we're doing something that is all probably familiar to everyone. So we've got, we've instantiated our LLM. So here we have GPT-4o, and now we're creating the agent, naming it assistant, passing it those tools, the LLM, the memory, turning off verbosity in this case, system prompt. We're adding the user message to the memory, and then now we're invoking the tool here. So request agent run with the message, and we're getting the response. We're adding that result to the memory as a result, and then we're getting the MCP metadata and tools. So basically the number of tools used, the actual calls that were made, and that overall metadata that we see. And then we give a structured response. So that's the gist of what's going on there. And then let's actually quickly, how we're doing on time, let's get to the actual tools that we were looking at. I think it should be in here. Yeah, okay. So we're using Vercel's MCP handler. So we're setting these initial instructions. And then, yeah, so here's examples of some of the granular tools that we saw when we were running the demo. Create projects. So, we're using Zod to um, sanitize and make sure the inputs are structured and known so we don't get unexpected stuff in there. And we're basically just going to call the API, make that post request with the arguments, and passing in the session. So, this project is basically the same pattern. It's just a different API being used in there. And task tool needs more inputs, different things going on there. So we specify that so we can have everything. You'll see a ton of things are optional, but when they're specified, they can get bound to the right parameters and executed. So again, we get our session, we populate the task data, then we call the create task, and as you can see, it just allows us to have much more success calling the tool when we sanitize all the parameters and have our checks in there. Get task tool, very much similar along the lines of other stuff we've run. List, okay, there's more things you can search for, so we've got some more optional parameters to control that search. But then again, it's just calling the API in the normal way, and then update task status, same type of thing. So you get the gist. It's nice in that it's very repeatable. And so these are the MCP tools that we use alongside the local tools. So I mentioned highly regulated identity previously, and we could take a look at what that actually looks like. So again, the advantage of using the sender constrained tokens is that if they are stolen, um, they're worthless. So they're worthless because the attacker won't be able to make a request without having um, the private key. So how do we use it? Well, before we used an Auth0 client, which was pretty much empty. Now we can just simply tell it to use Depop and the key pair that we pass in. So let me jump to actually a little further than I wanted to be. Okay, so yeah, so how do we generate key pairs? So we can basically use things like OAuth for Web API and or other methods to basically generate a key pair. And then we basically instantiate our Auth0 client by turning on Depop and passing in that key pair. That means at this point, we're able to basically use much more secure tokens that are protected from theft. You could also do it from environment variables, in which case you don't even need to pass in the key pair. You'll just set them to the expected environment variable name, and then they will just automatically get loaded in there. And here is a case of generating Depop keys using the SDK. So Here we do the basic imports. We generate the key pair. We grab the PIM for the cert and the private key corresponding to it. And so that's just another way you can do it. And then the more important thing is making Depop protected requests, right? Just if you don't do something with it, it's useless. So now that we have the key pair, it's basically you do something like Auth0 create fetcher. You're passing in the request, the base URL, and you're able to basically pull the settings, and then we can do overrides of the settings. Here we're explicitly disabling Depop or explicitly enabling it. So again, to use it, here we're creating the fetcher here, and then we're going to call the fetcher fetch with auth. And so we're putting in the endpoint, we're making the request, and as you see, it's basically looks like a regular fetch call, which is the whole idea. But because we configured it, we now have this protection handled automatically underneath. This is a page router example. It's going to basically look the same, which is what we want. So it really doesn't make difference. And then I talked briefly about things like the clock and tolerance and stuff like that. You have control there. You can control how much drift you can have between the client and server clocks. You could specify a clock skew if there's a if it's consistently ahead or behind. As it says, that's not usually something you need to worry about. And then you can add retries. So that's the gist of it. I'd like to see if we have any questions. Happy to answer.
Hey, Fred, thank you so much for that session. I was keeping an eye on the chat and I don't think we have any questions at the moment. Um, I noticed that the QR codes weren't working, so I put in all the different links that you shared with us earlier on the Discord channel. So that should be all covered. If any of you folks in the chat have questions, this is the perfect time for you to ask those questions. I can see someone in the chat saying that this was super cool. I wanted to let you know that folks in the chat have been loving this. There are also thank yous coming in. Yeah, looks like there are no questions. Fred, anything from you as parting notes that you want to tell them, and some tips and tricks that they should be following to be successful this week?
Yeah, hit me up in Discord or LinkedIn if you have any questions about if you're using this stuff and you run into any roadblocks. Just go ahead and ask away. On Monday, I'll be doing one specifically on AI agents. So just enjoy and have fun.
Thank you so much. Well, thank you so much, everyone who was joining us for this session. There's a lot more that we're doing this week. If you want to go quickly grab some water, go do that because we have another quick session starting in just under 5 minutes. So be there for that Sores workshop, but we will see you all later. Thank you so much again, Fred, for hanging around.
Bye,
See
everyone.
you. Bye.